In this video, I'm going to talk about complex fractions. There are two types of problems that we might encounter where we have complex fractions. A complex fraction is just a fraction made up of other fractions. The first type we might see is the type where there is only one fraction on top and one fraction on the bottom. When that is the case, we can treat it as a regular division problem. So let me give you an example of that. So if I have 7 over 18y over 2/9. As you can see, this is a fraction made up of other fractions. But since we only have one fraction on top and one fraction on the bottom, this is technically just a division problem with rational expressions. So this is equivalent to 7 over 18y divided by 2/9. And we should know that when we're dividing fractions, division is the same as multiplying by the reciprocal. So I just rewrote the problem as a multiplication problem, and we're now multiplying by the reciprocal of 2/9, which is 9/2. Once you get it to this point, you can do some simplifying if possible before you multiply. I see that I have a 9 and an 18 here, so I know I can simplify those. 9 goes into 9 one time and into 18 two times, and I think that's all I can simplify. Then I'm going to multiply straight across. 7 times 1 is 7. 2 times 2 times y would be 4y. So that's going to be the answer on that one. Let's look at another one. If I have a squared over 2a minus 3 over 5a over 8a minus 12. Okay, once again, this is one fraction or one rational expression on the top, one fraction on the bottom. We can work this like a division problem. So I'm going to have a squared over 2a minus 3 divided by this bottom fraction. I'm going to go ahead and rewrite it as a multiplication problem, multiplying by the reciprocal of the bottom. So I have 8a minus 12 over 5a. Now at this point, we would want to see if we can simplify anything, and when we have binomials or larger, the only way to simplify those is if you can factor them, and if we have identical binomials on the top and the bottom. 2a minus 3 will not factor, but 8a minus 12, we can take out a 4, which is going to leave 2a minus 3. Okay, now, so that's gone. The 2a minus 3's can cancel. I also see that I have an a here on the bottom and an a squared on the top, so I know I can take one a off the bottom and one of these a's off the top, which will leave an a there. So on the top, what I have left is 4 times a is 4a, and on the bottom, I have a 5. All right, one more like this, and then we'll go on to the other type of problem. We've got 5p to the 4th q over w to the 4th over 10p squared over qw squared. Okay, once again, one fraction on the top, one fraction on the bottom. This is just a division problem. The top fraction divided by the bottom fraction. We're going to rewrite it as multiplying by the reciprocal. So I have 5p to the 4th q over w to the 4th times qw squared over 10p squared. Then I want to see what I can simplify. I've got a lot of things here. I've got a 5 and a 10. 5 goes into 5 one time and into 10 two times. I've got 2 p's on the bottom, which is going to allow me to take 2 of these p's off the top, which will leave 2 left. I can take 2 w's off the top, which means I need to take 2 off the bottom, which in this case will also leave 2 w's left on the bottom. The q's will not cancel. They're both on the top. We can only cancel when one's on top and one's on bottom, because essentially when we're canceling, what we're saying is those are equal to 1 when you have the same thing on top and bottom, because anything over itself is 1. I think I've simplified everything I can simplify. So I'm going to see what's left. On the top I have a 1, which I don't have to write, a p squared, a q, and another q there. Q times q is q squared. So on the top I have p squared, q squared. And on the bottom I have 2w squared. Okay, now let's see what we're going to do when we have multiple fractions on the top or on the bottom. All right, when you have multiple fractions, on the top and or on the bottom, you're going to multiply everything by the LCD to clear the fractions. So if you're not clear on how to find the LCD, or the least common denominator, I have a video on that. So you just check my channel and look for my least common denominator video. And you might need to watch that first before you try to do this portion. All right, let's look at a problem like this. 1 over h plus 1 over k over 1 over hk. So as you can see, this one is different because I have multiple fractions on the top. So I cannot treat this just as a regular division problem. The easiest way to do a problem like this is to determine what your least common denominator would be for all of the fractions that you see within this rational expression or within this complex fraction. Okay, I see this one has an h, this one has a k, this one has an h and a k, and when we form our least common denominator, we've got to include one of every different factor that we see. So our least common denominator is going to be hk for this problem. All right, so that's what we're going to multiply everything by. And when I say everything, I like to write it on every individual rational expression. I like to show that I'm multiplying each one by hk, because then I can do my canceling for each one individually. Now the whole point of doing this is to clear your fractions. So if all of your denominators don't cancel out, then you've done something incorrectly, or you didn't choose the right least common denominator. All right, on this first fraction, the h's will cancel out. H over h, those are equal to 1, so that's gone. Here the k's will cancel out, and here the entire hk will cancel out. All right, so what is that going to leave me? Here it's going to leave me 1 times k, which is k. Here it's going to leave me 1 times h, which is h. So I have k plus h on the top over 1, which we do not have to include that in our answer. K plus h over 1 is just k plus h. Okay, so see how it nicely got rid of all of those fractions. That was our goal. All right, let's try another one. This one just has regular numbers. I want to show you that this will work just with regular fractions with no variables in them. If you have complex fractions made up of other fractions, I know how much all of you love fractions. So something like this, we can use this method on a problem like this as well. We would look for our least common denominator for all of the fractions in this complex fraction. We've got a 9, a 3, and a 6. I believe my least common denominator is going to be 18. Okay. Now, if you happen to use something that could be a common denominator but is not the least common denominator, it will still work. You'll just likely have to do more simplifying at the end. So if you can, choose your least common denominator. All right, so I'm going to take this and I'm going to multiply every one of these fractions by 18. And the goal of doing that is to clear these fractions or get rid of these denominators so we don't have fractions anymore. So here I have a 9 and an 18. And 9 goes into 18 2 times. And here I have a 3 and an 18, and 3 goes into 18 6 times. And here I have a 3 and an 18, and 3 goes into 18 6 times. And here I have a 3 and an 18, and 3 goes into 18 6 times. And here I have a 3 and an 18, and 3 goes into 18 6 times. And here I have a 3 and an 18, and 3 goes into 18 6 times. And here I have a 3 and an 18, and 3 goes into 18 6 times. And here I have a 3 and an 18, and 3 goes into 18 6 times. And here I have a 3 and an 18, and 3 goes into 18 6 times. And here I have a 3 and an 18, and 3 goes into 18 6 times. And here I have a 3 and an 18, and 3 goes into 18 6 times. And here I have a 3 and an 18, and 3 goes into 18 6 times. And here I have a 3 and an 18, and 3 goes into 18 6 times. And here I have a 3 and an 18, and 3 goes into 18 6 times. And here I have a 3 and an 18, and 3 goes into 18 Here I have a 6 and an 18. 6 goes into 18 3 times, and another 9 and an 18, and 9 goes into 18 2 times. All right, so let's see what's going on here. Here I'm going to have 2 times 8 is 16, minus 1 times 6 is 6. That's what's left on the top. On the bottom, I'm going to have 3 times 7 is 21, plus 1 times 2 is 2. And that simplified this a whole bunch. 16 minus 6 is 10. 21 plus 2 is 23. So this is equal to 10 over 23. All right, let's do another. We have 2 plus 1 over x over 4 plus 1 over x. Okay, so once again, we're looking for the least common denominator for everything that has a denominator. Now, we don't have to worry about 2 and 4. Those are whole numbers. They don't have a denominator other than 1. So we're really just looking at x and x, and those already are in common. They both have the same denominator, so that's our common denominator, x. So we're going to take all of the terms, even these whole numbers, and we're going to multiply them by that common denominator of x. Okay, so nothing's going to cancel out on these. Once again, these are on top. This is going to get multiplied by the x, but nothing cancels out. Here, the x's will cancel, and here, the x's will cancel. All right, so I'm going to have 2x plus 1 on the top, and 4x plus 1 on the bottom. Now, don't get crazy and try to do something like cancel these ones. Remember that a binomial is one thing. 2x plus 1 is one thing. Unless we can factor something out of that, or unless we have another 2x plus 1 on the bottom, we can't mess with this, okay? So that's in as simple of a form as we can get it. So we're leaving it like that. All right, let's do another one. All right, 2 over p plus p over 2 over p over 3 minus 3 over p. All right, so again, we're looking for least common denominator for all the fractions that we see within this problem. I see p's, I see a 2, I see a 3. So for the number part, for 2 and 3, we're going to need a least common denominator of 6, and then we're also going to have to add to that a p. And that kind of covers everything. So our common denominator is going to be 6p. That's what I'm going to multiply each fraction by within this complex fraction. And that allows me to do some canceling. Here my p's are going to cancel. Here my 2 and my 6 are going to cancel. 2 goes into 2 one time and into 6 3 times. Be really careful when you're crossing these out. Don't get sloppy and mark out the whole 6p, or you're going to lose terms that you need. Same thing here, just the p, and here just the 6 simplified. All right, down here just the p, and right here 3 goes into 6 2 times. All right, so let's see if we can come up with what's left. In this first one, we have 6 times 2 is 12. In the second one, we have a 3 and a p and another p, so that's 3p squared. So all that's being multiplied. Down here, we have 2 times p, so that's 2p squared. And here we have minus 3 times 6, which is 18. Now, in order to see if that will simplify it all, we should try to factor anything that can be factored. I see that on the top here, I can factor out a greatest common factor of 3. which is going to leave me with 4 plus p squared. On the bottom, I see I can factor out a greatest common factor of 2, which is going to leave me with p squared minus 9. And then hopefully you recognize p squared minus 9 as the difference of squares, which means it can be factored further. The top cannot, because this is the sum of 2 squares and we do not have a way to factor that. But the difference of 2 squares, that will factor to p plus 3 and p minus 3. Now we did all that factoring and nothing ends up being able to simplify, but that's okay. We still always want to give our answer in factored form. So always go ahead and factor anything that can be factored. That will be the only way you'll be able to see if it will simplify. Okay, I think we should still do a few more. Let's try this one. 1/5 minus 1 over y over 7/10 plus 1 over y squared. Okay, least common denominator. Let's look at the number part first. For 5 and 10, we would need a 10. When you have y's and y squareds and any y raised to a power, when you're finding your common denominator, you always want to choose the higher power to go in your common denominator. So we're going to need a y squared. So a 10y squared is going to be our common denominator. So I'm going to go through and I'm going to multiply everything by 10y squared. All 4 of these fractions. Again, you want to be careful when you start to cancel things out that you only mark out what's canceling out so you don't lose anything you need. Alright, so for example here, the 5 and the 10. 5 goes into 10 2 times. Here we can cancel one y off the bottom and one of these y's off the top. Down here, 10 and 10. And down here, y squared and y squared. So let's see what we have left. We have here 2 times y squared times 1, that's 2y squared, minus 1 times 10y, so 10y, over 7 times y squared, and down here plus 10. Okay, I don't see anything that will factor on the bottom, but on the top I do see that I can take out a 2y, a greatest common factor of 2y. So the top will factor to 2y times y minus 5 over 7y squared plus 10. Now we cannot cancel anything, simplify anything further. These y's are part of this binomial, so don't try to cancel y's here. That's as far as we can get. All right, let's see. One minus 4 over a squared over 1 minus 2 over a minus 8 over a squared. Okay, we got a whole lot of fractions going on here. We need to find the least common denominator for all of them. I have an a squared, I have an a, and I have an a squared. And like I said up here, if you have a's to different powers, you need the highest power that you see in your common denominator. So our common denominator for this one's going to be a squared. That's what we're going to go through, and we're going to multiply everything by a squared, even the things that aren't fractions. Every single part has to be multiplied by a squared. Okay, so let's see. Nothing will cancel here. Here, the a squareds will cancel. Nothing will cancel here. Here, 1a off the bottom, 1a off the top. Here, the whole a squared and the whole a squared. So what we've got left is we have a squared times 1 is a squared minus 4 on the top. On the bottom, we have a squared times 1 is a squared minus 2 times a is 2a minus 8. That looks a lot better. And I do see some things that can factor, so I'm going to do that. On the top, you have the difference of squares, which will factor to a plus 2 and a minus 2. On the bottom, you've got a trinomial with a leading coefficient of 1. We're looking for two numbers that multiply to get negative 8 and add to get negative 2. Those are going to be negative 4 and positive 2. Now once we do that, we see we've got some matching binomials. A plus 2 over a plus 2. We can cancel those out. That just becomes 1. So we are left with a minus 2 over a minus 4. That's our final answer. All right. I've got one more problem for you, and then you ought to be good to go off and do it on your own. 3 over y minus 3 plus 4 over 8 plus 6 over y minus 3. Okay, so we've got a fraction here and a fraction here. They both have the denominator y minus 3, so that's going to be our common denominator. It's a binomial this time. We haven't had one like this. You do it the same way. You're going to multiply everything by that binomial. I like to keep him in parentheses since he's a binomial. Just so I don't forget. Okay, so let's see. Here, our y minus 3's can cancel. And also here they can cancel. Nothing's canceling here or here. But what we have to be careful of when we have a binomial that we're multiplying by is when we get to this side, we have to distribute. So here we just have a 3. On this part, we have to distribute. So 4y minus 12. And then on the bottom, we have to distribute here. 8y minus 24, and then plus 6. All right, I see some like terms we can combine on the top and on the bottom. So on the top, I'm going to end up with 4y minus 9. Positive 3 and a negative 12 make negative 9. On the bottom, I'm going to end up with 8y minus 18. Now, we always want to check to see if anything will factor. The top definitely will not, but on the bottom I do see that these are both even numbers, which means I know I can factor out at least a 2. And when I do that, you see what happens. I have these nice matching binomials. Now don't forget, when we cancel these, essentially it's becoming a 1. So it's not, your answer is not just a 2. That 2 is on the bottom, and we'll put a 1 on the top, and so 1/2 is our final answer there.